So how do you actually do a recursive function in Java? How do you do a recursive method or function in Greenfoot? So I already did the work so that you don't need to watch me programming it. So what I did is that I created this round circle of balloons using a normal for loop. So that means this is what we will call an iterative approach to drawing balloons in a circle. And this one I created using a recursive function or a recursive method where the balloons draw each other, and I'll show you the difference. So if we go into the My World where I'm doing all the work, and I like to see the balloons, like to see the balloons while we're looking at the code as well. Maybe zoom in a bit. No, doesn't work. So if we look here, I have two methods here. I have one I just call iterative balloons, and that calls the method down here. And what we can see here is we're using a normal for loop and then some mathematical calculations to actually draw this. And in here, there's actually no loop. So the weird thing is that normally in here, I'm actually creating a lot of balloons. But in here, I can't see, I only have one place where I'm adding and creating a new balloon. So how can it be that I can create all of these balloons? There's actually 90 balloons here, I know that. So how can I create 90 balloons if I only have one add object here? So it's somewhat like what I do in the for loop here. I define some saying that I needs to be smaller than something, and then I increment until I reach that goal. So here what I do, I'm using kind of this inception trick, and I'm going to explain that. So let's first understand what I'm actually doing here. So let me explain iterative balloons first. So in this method, I'm using a way of describing where the balloon should be put on the world based on the center of a circle. So I can describe every point on a circle this way by saying that the x-coordinate should be the starting point, and that is the middle of the circle. And then I add the radius multiplied by math.sine of I. And I in this case is some radian, is the angle in radians that I'm looking at. So it's kind of like you taking a stick and then drawing it. Let me just briefly try to show that. So the idea behind this is some math, right? So we have a center here of the circle, which is x dot y dot, and we have this thing here, which is the screen, which starts at 0.0, and then it goes to, in my case, it goes to 1200 in this direction, and it goes to, I think, 900 in this direction. So the maximum value for y is 900, and the maximum value for x is 1200, and this gives us this to work with. So I'm setting the x dot to 900, which is somewhere around here, and the y dot to 450, so that is around the half of the screen. And what I need to do then, I need to calculate what the x and y is for this. So if we look at the points on the circle, if we go here, for example, no, let's start here. So this is at 0 radians, or 0 degrees if you're more used to that. This is the basis, we're going this way. So the formula for this is the radius here multiplied by math.sine of I. And because I here is going to start at 0, math sine will also give us, this will just give us 1. And this way we'll just add the radius to get this point here. This means that I know this is the x-coordinate, it's just x plus the radius actually. And in the cosine, the cosine is going to be 0, this value, so we're not going to add anything to this, so this way we can map that. So I'm drawing the first balloon here, right? So this is my first balloon, and then we go further and I add some step to it. I could have just added one, but then it would have very few balloons, so I added up a bit less than one. And don't worry about this math pi thing, it doesn't really matter, it's just a number of increment. So I then calculate for the next balloon here with the we can use sine for getting the opposite value here, and cosine for getting the x value here. So this way we can keep calculating the next place for the balloon. So this is basically how it works. So what I do is I just run through what I know will become a complete circle, and then it actually draws this, right? So what I did then, I thought, can I make this into a recursive algorithm? And my idea was, let's just draw a balloon somewhere on the screen. So I draw a balloon, and after I've drawn the balloon, I'm just going to say, what if I just move the balloon, the next balloon, I just move it a little bit to, kind of like I imagine I'm now going to move it with this arrow to this next point, and then I'm going to turn a bit again and move to the next point and turn a bit again and move to the next point. And each time it's kind of like the balloon itself creating the next balloon. It's sending, this balloon is sending the data to this balloon to know the last balloon was here, now I'm going here. And the way I've done that is I used the same calculations as down here. I did just multiply by 10 because otherwise I would need a lot of balloons, and that's just to move it a bit further each time. But I'm turning a little bit each and every time, and then I multiply by 10, and this way I create the same circle like this. So I only have one place where I'm adding the balloon, like here. So I'm calculating the new value for x and new value for y based on the last value that I got. The first time I run it, it's 250 for 50. So we know this is 250 in the x direction, and this is 450 in the y direction. And what I do then, I just use turn. I call it turn, but it's really the angle in radians that I'm calculating here. And then I'm saying add object balloon, and then calculating the next point. And then I'm saying if the maximum number of balloons is larger than 0, then I'm going to send the values, the new values of x and y, I'm sending those to the next balloon. I'm also sending turn plus some number here, which is the how much I'm going to turn each time I go for the next balloon. And then I say, now I already did one balloon, so now my next balloon is -1, my max balloons is -1. And the reason why I'm doing this is because if I didn't put this max balloons thing in here, it would just keep on going forever. So if I remove this if sentence here, it would just, each of these calls to this method would say recursive balloons, it would draw a balloon, and then it would ask, it would call itself again, and this is the recursiveness. So you see the name here, recursive balloon, is actually the same method as up here. So I'm starting the algorithm here by calling recursive balloons, setting the first starting point, setting the initial turn to 0, and then setting the maximum of 90 balloons, and that just means there's 90 balloons in the circle here. And each time I put down a new balloon, I count down my max balloons by 1. So the next balloon gets the new value of x and y. It gets the same turn as the last one, plus a bit more, and then it gets max balloons -1. So that means that when I get to the 90th balloon in this case, because I put 90 here, it stops because it no longer goes further down the recursiveness. So you could also say I made a recursive function. Let me just clear this. I made a recursive function called recursive balloons. Let me see if I can just... And, okay, can I... Uh, just let me edit this for a second. Can I make it bigger? No. Okay, so I made this method here, recursive balloon, and this method will just call another method. So the recursive balloon will call a recursive balloon, which is really itself, but the difference is that the recursive balloon now has different parameters. So each time of this recursive call, I change into the new x and y value, and I also add to the turn and subtract from the max balloons. So if we have one state here which is the where the max balloons is 90, then I call it again, and then it becomes 89, and I call it again, and then it becomes 88, and then I call it again, and so forth until I hit 0. Then it won't draw a balloon because then max balloons is no longer bigger than 0 and it's no longer calling itself. So one thing you have to be very careful with when you're doing these recursive methods is that you have some kind of stop clause or something that will make it at some point stop calling itself. Otherwise, you will actually get into an indefinite loop, which is kind of a special one. It will give you a stack overflow at some point because there's no more room for any more methods on the call stack. So I don't know if we can, let's see if we can do that, or it will just hang. A Greenfoot can sometimes be a bit... So you see here, something is going on here. So probably I can't find the beginning of this. Yeah, I could. You see stack overflow error because it keeps calling itself over and over and over again. And now I probably broke something, right? So it's very important, and if you ever get a stack overflow error when you're doing recursive methods, it's because it's going into an indefinite loop. If I put the other one here, my iteration into an indefinite loop, it wouldn't give me a stack overflow error because I can just keep going and going and going, and the program would just hang instead. So if I do something stupid like say I equals 0 here, then it would just freeze the program forever. It would never know when to stop. I do think though that, yeah, it says execution time is taking long. You may terminate by using this button down here. So it doesn't know if it will ever finish. I do know that it will never finish, so I'll just say terminate execution and then remove this. So that's the difference between iterations. They will just keep going, but the recursive balloons will actually go too deep into inception, go into the deepest level of inception and say there are limits to the amount of inception levels we can go with recursion. So what to look out for is when you're calling itself, there should always be something like checking something to see, am I going to stop this at some point? And you'll also see that in my other examples. Yeah. So that's it for the very basics of these. And the balloons and this circle was just to illustrate how we can use recursiveness instead of iterative approaches for creating somewhat the same thing. There's not the same amount of balloons and parameters and stuff like that, but it's more just to show the idea that we can think differently and then create the same thing by using recursion. This is not a very effective way to draw balloons, though. There are other ways we could do that. I'll show some more tricks and stuff like that in the next videos.